Hi guys, this is Catia. I'm from Tech Designs, and today we will see that how to make a piston in Catia V5. Catia V5 have different workbenches. Currently we are in GSD, that is generative shape design. But to design the piston, we should be into the part design. So this is the entire user interface of part design in Catia V5. As a designer, you should know that in Catia V5 we should work in an access system. Generally in industry, you'll find that these three planes should be hide and we should work on this access system. The benefit of this that we have 3 axes and 3 planes, and this axis system is parametric. These planes are not parametric, so working on these planes is not suitable in Catia V5. Usually in automotive industry you work like this only. So moving further, we'll sketch on any of this plane. Let's say ZY plane we are sketching. For a revolve feature, like a round feature, if you have seen piston is round, so for that we'll use revolve feature. So for revolve feature there should be a revolving axis, and we'll make a feature on one side here, and that will revolve around this axis. So let's say first of all we'll make a profile. So this is the profile feature in this in sketch. This is rectangle, circle, spline. We have many features here. So what we do is we generally make it like this. In any software, in any CAD software, there are numerous ways to design a part, and you can design a part in a single feature, you can design a part in multiple features. It's totally depend how you want it. So right now I'm designing it to make you understand the basic phenomena of designing in Catia V5. So here we'll give the dimension. In Catia V5 there's a very nice option that if you don't want to select a feature again and again, just make it a double click, so it will be selected unless you press an escape. So I want this to be, let's say, 35. I want this and this. Okay. I want this to be 10. I want this. See, here one more thing. You can see pink lines, green lines, white lines here. So what does it mean? Alright, so here if I give a dimension, like you can see 35 here and 35 here, this is over constrained, so I have to delete one. Now you'll see all the green lines, so that means that this sketch is now fully constrained. You can have you'll see you have the vertical constraint, the horizontal constraint, and the coincidence constraint. All these constraints are there. So if you want to change this dimension, I want it to be 45. Alright, so this is the basic profile of our piston. Okay, so we are coming out from the sketcher. Now you can see that our sketch is here. Here's the revolve shaft command. by which this complete profile will be revolved around this axis. But one more thing, that there's a part body in here. I prefer that you should not make a feature in part body, because part body is again non-parametric. You cannot move your part body, you cannot the part body is, you can say, is the main body. If you do not insert any body in your tree, then everything will go in your part body. So I prefer to insert a body in the tree than work. Again, same things goes with the geometrical set. The geometrical set is a folder kind of thing in which all of your sketches, all of your surfaces goes. So there should be a geometrical set, and whenever you go and work, you want to work in this geometrical set, for example, you have to make it like defined in work object. You can see it is underlined now it's active. Now whatever you do, that will go inside this geometrical set. So now we'll be working in this body too. Okay, and then we'll select this shaft and select this. Okay, so now you can see this is a complete revolve feature. Alright, so again, now we are going to make some more profiles. So this is our axis system. Again, we're gonna sketch here like this. Alright, so again, the center axis by which our sketch will gonna be revolved. Now we are going to make profile for gaskets and rubbers. Let's say we have two profile for this. Let's say in our piston there will be two profiles for gasket. Now again, we're gonna make dimension for this. There are very specific pattern to give the dimensions in your sketch, because in this in software like this, you should give your dimension like that, so that it can be reflected directly in your part drawing. So you should take that dimension directly from your sketch. That will go in your 3D model, and from your 3D model it will go in your manufacturing drawing. So it should be very precise, it should be very parametric, and it should be very genuine thing. So if you want to change one dimension, the other dimension should not be changed. So this is the basic fundamental while making a sketch or while making a 3D modeling. So here we have given, so here you can see that we have made this sketch very much constrained. Now we'll go outside of the sketch. Now we'll again make this body 2, defining work object. Alright, so this feature shaft is to add material. Alright, now this feature groove is to remove material from an existing material. So if we are selecting this, you can see the material is moved. Alright, now we have our outer profile something like Piston. Okay, so piston is hollow from inside, so we have very much perception that we should give a shell feature here, but while giving a shell feature we should not we should take care that it will give a uniform wall thickness, and that uniform wall thickness will go around this profile also. So we'll make a feature here that will remove the material. So this is another way to select a feature and make it like this. Alright, so now we'll make a circle here, and I select this circle, I select this, and we'll give a constant that is concentric. Now these two round profiles are concentric, and what we are going to do is to give dimension to this circle. It's 35, no, 50. I think that's good. Okay. Now we'll make it, let's say 40, so that diameter of 50 is and 40 depth, the material is removed. Okay, it's looking like some sort of piston. You can make it more complicated and more robust design. Alright, so what we're gonna do is we are going to provide a feature that will support the connecting rod to be attached with piston. So this is 10 in diameter, and this is the pocket which will remove the material. We will extend, and you can see that well, I think this will give you some idea that how to design a piston in Catia V5. Catia V5 is a software in which you can do anything. You can make surfaces, you can make parts, you can do free modeling, you can do anything in this software, and you can find everything here on Pointer Tech Design YouTube page. Please like, share, and have fun. Happy CADing, happy Catia V5.